Okay, this is page 6 of Arithmetic Sequences series challenge page. So I just put all the tough problems on this last page. Um, and so, do as many as you can, or at least watch this video. I think it's good to think about these. Really tests your understanding of Arithmetic Sequences series. The nth term of the arithmetic sequence is u to the n equals 42 minus 3n. Calculate the values of the first two terms of this sequence. Now that's not too bad, is it? So you put un equals 42 minus 3n. Now you don't know u1, you don't know d, but they gave you an expression which calculates un, so you don't really need to know u1 or d yet. Okay, so u1 is equal to 42 minus 3 times 1. So that would be 39, right? Okay, and then, so you found u1, and they also ask you to find u2. So u2 is equal to 42 minus 3 times 2, which is 42 minus 6, which is 36. Okay, so now you already kind of know d, right? D, by the way, is this minus this, so that would be negative 3, right? D is negative 3. Okay, now let's move on. Which term of the sequence is negative 9? Okay, so remember the formula. un equals u1 plus n minus 1 times d. So they're saying which n corresponds to negative 9. Negative 9 equals u1, we know is 39. And, we don't have to use this formula. We could actually use their formula. Why don't we do that? Because I think that's what they expected us to do. So, which term of the sequence is negative 9? So we'll go un equals 42 minus 3n. So we'll put negative 9 equals 42 minus 3n. And then we do negative 42 minus 42 from both. This would be about negative 51. This would be negative 3n. Divide both sides by negative 3. N is equal to 51 divided by 3 is about 17. Okay, so n equals 17. So the answer to B is 17. Two consecutive terms of the sequence, uk and uk plus 1, have a sum of 33. Find k. Okay, this is the difficult part. So there's the kth term and the k plus 1th term have a sum of 33. So let's say uk is equal to 42 minus 3k. uk plus 1 is equal to 42 minus 3k plus 1. And the thing is, if we add these two together, we're going to get 33. So 42 minus 3k plus 42 minus 3k plus 1 is equal to 33. Okay, now we find k. So we have 42 and 42. That adds up together to be 84. Minus 3 times k plus 1 would be minus 3k minus 3. The minus 3k's you can put together, you get minus 6k. And then we still have minus 3 here, equals 33. Okay. Now to get the k by itself, we can subtract 84 from both sides. We add 3 to both sides. And then we end up with negative 6k on the left. And we end up with 33 minus 84. That would be about 51, negative 51, plus 3, that would be negative 48. So k would be equal to, and you can figure that out, right? And then k plus 1 would be just 1 over that. So they ask you the two consecutive terms, uk and uk plus 1. They want to know what k is, okay? Okay. 2. The first three terms of arithmetic sequence are k plus 4, 5k plus 2, and 10k minus 1. Show that k equals 2. The first three terms of an arithmetic sequence are, okay, show that k equals 2. Okay. All right. So, if these are three consecutive terms, then if I take the difference between each of them, then I should get the same amount, right? So if I take the third term, 10k minus 2, and I subtract the second term, 5k plus 2, that should be equal to 5k plus 2, the second term, minus the first term, k plus 4. Because that should equal the common difference, right? So let's just simplify this. Minus 2 minus 5k minus 2 equals 5k minus k plus 2 minus 4. 5k minus k is 4k minus 2 equals 10k minus 5k is 5k minus 4. So then we subtract 4k from both sides, and we end up with k minus 4 equals minus 2. And then if we add 4 to both sides, it gives us k is equal to 2. So we found what they want us to find. Find the values of the first three terms of the sequence. Okay, now that we know that k equals 2, that's not so bad to do. I'm just going to erase this part here. Okay. So the first term is k plus 4. And if I put 2 in there, it's equal to 6. The second term is 5k plus 2. And if I put 2 in there, it's equal to 12. The third term is 10k minus 2. And if I put 2 in there, it's equal to 18. Okay, so we just found the first three terms. Write down the value of the common difference. Well, the difference between these two is plus 6. The difference between these two is plus 6. So I think we just found the common difference is 6. Calculate the 25th term of the sequence. Okay, well, the 25th term is u25 equals u1 plus n minus 1 times d. And we know d is 6. And we know n minus 1 is 24 because it's n equals 25. And u1 we know is 6. So u25 is 6 plus 24 times 6. And that's about equal to 150. Okay? Now, find the sum of the first 25 terms of the sequence. Okay, well, S25 is equal to U1 plus U25 times 25 divided by 2, which is n divided by 2. So U1, remember, is 6. U25 is equal to 150. 25 divided by 2. So you can figure that out, right? 6 plus 150 times 25 divided by 2. And that is S25. Okay. Find the sum of this arithmetic series. You have U1 equals 26. You have D equals, let's see, looks like in between each of these you got negative 1.5, right? And un is equal to negative 17.5. So find the sum. Well, we know that the first term is 26. We know that the last term is 17.5. What we don't know is n. So how do we figure out n? Well, we have a formula that figures out n, which is this formula, right? And we know that negative 17.5 is the last term. 26 is the first term. We don't know what n is, and we do know that the d is negative 1.5. So we can solve for this by using algebra, right? We can figure out what n is equal to just by, we subtract negative 26 from both sides, and then we're going to end up with some messy number here, and then we divide the number by negative 1.5, and then we add 1, we get n equals something, okay? Then we take that n, and then we're going to put it in the expression for Sn, okay? And we'd have the u1, which is 26, and we have un, which is negative 17.5, and we just put the n here, and we divide by 2, and we find what the sum of the series is, because we know n. I'll leave that for you to do. The first three terms of an arithmetic sequence are 4k minus 2, 3k plus 4, and 6k. Show that k equals 2.5. this is similar to the one we just did above. You know, the first term is 4k minus 2, the second term is 3k plus 4. So you can find the common difference by taking 3k plus 4 and subtracting 4k minus 2. And if that's the common difference, then the third term, which is 6k, subtract the second term, which is 3k plus 4, is also going to give you the common difference. And so let's see. Let's simplify this. So 3k minus 4k is negative k. 4 minus a negative 2 is 6. And then we have 6k, and then we have minus 3k, and then we have minus 4. 6k minus 3k is just 3k. And then if we subtract 3k from both sides, we get negative 4k, and then we subtract 6 from both sides, we get negative 10, and that gives us k equals 10 fourths equals 5 halves, k equals 5 halves. Okay, and that is equal to 2.5, which is what we wanted to show. Find the value of the first three terms of the sequence. Okay, the first term is 4k minus 2, I'm sorry. And if we put 2.5 into that, that gives us 10 minus 2, which is 8. The second one is 3k plus 4, which is 7.5 plus 4, which is 11.5. And then we have 6k, which is 15. Okay, so those are the first three terms. Write down the value of the common difference. The common difference would be plus 3.5. Okay. Calculate the 15th term of the sequence. That would be U15. U15 is equal to U1 plus 14 times D, which is 3.5. And U1 we know is 8. So 8 plus 14 times 3.5 is the answer to U15. And then once we have U15, then we can find S15 by taking U1 and adding it to U15 and then multiplying it times 15 divided by 2, right? And so the U1 we know is 8, and U15 we can get just from here, right? This is 3.5, okay? So you can figure that out, right? Last one. Mr. Zhang decides to increase the amount of money he gives to charities by P yen every year. In the first year, he gives A yen. In the 6th year, he gives twice as much as in the 3rd year. So every year, he increases by P, A plus P, A plus 2P, A plus 3P, right? In the first year, he gives A yen. The 6th year, he gives twice as much as in the 3rd year. So the 6th year, which would be, let's see, this is the 1st year, this is the 2nd year, 3rd year, 4th year, 5th year. The 6th year, it'll be A plus 5P, okay? And that happens to be twice as much as this. So A plus 5P is equal to twice as much as the 3rd year, which is A plus 2P. In the 10th year, he gives 4,000 yen. So the 10th year would be A plus 9P. That's the 10th year. And that's equal to 4,000. I don't think they realize that 4,000 yen is only $40 because Mr. Zhang is a real cheapskate besides being Chinese instead of Japanese. Okay, find the value of P and A. Okay, so A plus 5P is equal to 2A plus 4P. We're just going to make a relationship between A and P. Subtract A from both sides, subtract 4P from both sides, and we end up with P equals A. Oh my gosh, so P is equal to A. And then we also know that A plus 9P is 4,000. So since we know that A is equal to P, we also know that A plus 9A is equal to 4,000, which means 10A is equal to 4,000, which means A is equal to 400. So man, what a cheapskate. His first donation was only 400 yen, which is basically $4. And then every year he gave 400 more yen. Okay, so A is 400 and P is also 400 yen. Mr. Zhang, what a cheapskate.